Okay, today we are going to continue on Boyles Law Problems. In order to do this worksheet, you're going to need a calculator, and that is it. Please write these formulas at the top. I'm going to zoom in so you can read it, and then I will move it around. Make sure this is written at the top. It'll be much easier to do the worksheet. On the top right up here, I'm just putting the conversions to get to ATMs. Sometimes you'll have 8 mmHg. I want you to know that's the same thing as torr. These are interchangeable. And kPa is another unit that you might see for pressure. And again, we'll need to convert it to ATM, which stands for atmosphere. I'm going to show you how to use this chart in a second. We've seen it before in doing our moles to grams. This will also help us do some of our other conversions. Right here in the center, this is Boyles Law. Please remember, Boyles Law deals with pressure to volume. Just by looking at the equation written in this way, is this going to be an inverse relationship or a direct? Anyone? Inverse relationship. Good job. Meaning if pressure goes up, volume needs to do what? Okay. If pressure goes up, volume needs to go down. We're going to scoot it over this way. I'll give you another minute and then I'm going to start. Okay, let's take a look at number 1. If you want to do this on an extra sheet of paper, that's fine because it will get messy. Given that this is our formula, will we need to do anything with temperature? Miguel? Do we need to include temperature in our formula? No, we do not need temperature. So that's just added information. Right away though, I do see torr. So we're going to need to convert both of these to ATMs. Going to zoom in a little bit. Okay, it says in order to get 1 ATM, I need 760 torr. I'm given 742 torr. So is this even going to give me 1 full ATM? No, because I need at least 760. So that should tell you that you will get a very, very little number. If you want to follow along, and I'll show you how to use this to convert whatever I was given, 742 torr. And what do I want? 1 ATM. These units have to match. So I know this is going to be torr. And I'm going to use this number. This is the conversion unit. 742 and 760. Am I going to multiply or divide these? Yes. So 742 divided by 760. 0.97. So this is going to be my P1. I'm going to do the same for 795. And this is my P2. So I have my P1 and my P2. I'll give you a minute to write that down. So now I'm looking for volumes. It says a container holds 500 milliliters. We need to convert that to liters. So we just divide by 1,000. So this will be my V1 equals, I'm just going to make a top note at the top really quick. Milliliters to liters, divide by 1,000. Everything needs to be in liters. I'm going to go back to the problem. I have my V1, my P1, my P2. The question says, what will the volume be? So I'm looking for V2. Going to zoom out a little bit. Now I'm going to plug in everything in this formula. So my P1 is 0.97. My V1, P2. Go ahead and solve for this and I'll call on you for the answer. Again, I'm trying to squish everything on the paper so you guys can see what I'm doing, but you can do this on a separate sheet of paper. Jonathan, what did you get for V2? I'm going to wait for you. No. James, what did you get? Yes, 0.46. Did anyone else not get 0.46? So that's what V2 is. Volume is in liters. And let me just walk you through what I did. After I put in my P1, V1, P2, V2, I multiplied this side first, 0.97 times 0.5, and that's what gave me 0.485. I dropped all this down. To get V2 all by itself, I need to get rid of 1.04. So I divided by 1.04 for these to cancel, and then I did 0.485 divided by 1.04. Does anyone have any questions? Okay, let's move on to number 2. It says a gas tank holds 2,785 liters of propane at that pressure. What's the volume of propane at standard? So this is going to be our V1. Our P1 is 830 mmHg. I need to convert that though. I want ATM. The conversion for mmHg is 760. So I just do 830 divided by 760. So So this is my P1. The question is asking what is the volume. Therefore, I'm looking for V2 of propane at standard pressure. So they already gave me P2 is standard pressure. What's standard pressure again? Yes, 1 ATM. Let's get it up. Okay, so I already have everything I need. I have my V1, P1, P2. I'm solving for V2. I'm using the same formula for all of them, which is right here. I'm going to scoot it over where I have some room. I'm going to multiply these two numbers first. And of course, when you divide anything by 1, it remains the same number. So my V2 stayed that. This is my final answer. Does anyone have any questions on that one? Let's look at number 3. A balloon contains 7.2 liters of helium. The pressure is reduced to 2 ATMs, and the balloon expands to occupy volume of this. So this is my V1. This will be my V2. It says, what was the initial pressure? So that gives us a clue that that's what we're solving for. We don't know what our P1 is. So that means the only other ATM pressure number in there is our P2, which is 2. So we have all the data and then we solve. I'm going to go ahead and let you solve for 3, but I'm going to help you set up number 4. So just follow along and you can go back to 3. For number 4, it says a sample of neon occupies a volume of 461 milliliters at STP. STP is standard pressure, which equals how many ATMs? 1. It says what will be the volume when the pressure is changed? Okay, so V1 is 0.461 liters. P1 is 1 ATM. We're solving for V2. It says what will be the pressure? It's always good to identify what the question is. V2. Oh, wait. Yeah, that's V2. Sorry. I lost track of what I was doing. V2. Yeah. Okay, but it's in kPa, so we do need to convert. So to convert, it gave us 93.3 kPa. I want ATM. The conversion for kPa is 101.325. So I'm going to take 93.3 divided by 101.325. Did you guys get 0.92? Okay. And that will be my P2. So you do have all the variables you need to solve. I'm going to let you try to set up 5 by yourself. Just remember that milliliters needs to be changed to liters. We don't need anything to do with temperature. And you need to convert these MMHGs to ATMs.